meters, 10 meters, 5 meters. That means this wouldn't be a v-axis, this would be an x-axis, all right? So it would be an x position axis, okay? So we'd be looking at V1 equals 15 meters, V2 equals 20 meters, okay? So you just got to pay attention to your axes and your units to know how to label these. Are you going to label it X or are you going to label it V? All right, great. So now we have all of our points. Now it becomes pretty simple. We just have to plug it into the formula. So let me scoot this board over a little bit. So the formula that we're working with is, I'll use Brown. So the formula is delta V over delta T, right? That is going to be rise over run. That's how I like to remember it. Which axis is rising and which axis is running, okay? So rise over run is going to be the V axis, which we label as delta V, over the T axis, delta T. All right. So now I know I'm going to have V over T. Now remember, when we have delta anything, that's going to be the second minus the first. So delta V is V2 minus V1. Delta T is T2 minus T1. Okay. So now we can go ahead and plug in our variables. We know V2 is equal to 20 meters per second and V1 is equal to 15 meters per second. We know T2 is equal to 4 seconds and T1 is equal to 2 seconds. All right, because we already labeled all of that information on our graph. So it makes it easier as we do the problem. So now we're going to go ahead and solve this. So 20 minus 15 is 5, so 5 meters per second. And then 4 minus 2 is going to be 2. So we end up with 5 divided by 2. All right, I'm going to go ahead and divide that. 5 divided by 2 equals 2.5. All right, and now meters per second divided by seconds. All right, you could use the keep change flip rule on this. All right, so we'll actually do that on the bottom over here, just so that you all can see that. And let me do it in green to make it stand out. So we've got meters per second divided by seconds. All right, meters per second divided by seconds. Okay, so I use the keep change flip rule, which changes this to meters per second. I keep that, change my sign from division to multiplication, and I flip my seconds. So it's S over 1 right now. We're going to make it 1 over S. Remember, the reason it's S over 1 is because anything divided by 1 is itself. So we can assume there's an imaginary 1 under this S. Now when I multiply this straight across, that gives me meters up top and seconds squared in the bottom. So I know my final answer is going to be 2.5 meters per second squared. Okay? So I have my answer, I have my final units. This is a unit of acceleration. Now we also know that makes sense because a VT graph, velocity time graph, the slope of that will tell you acceleration. So let's write that up here. Slope of a VT graph tells you acceleration, which is in meters per second squared. So we know that this just told us the acceleration. All right, now let me box that in red. Now, just so that you all are ready for your other problems, the slope of an XT graph tells you velocity because you're going to have meters over seconds, and meters over seconds is a unit of velocity. All right. So I hope this was helpful to you. If you have any questions, you can look at some of your previous work. Like I said, we've gone through these problems before, but this is how you solve for the slope of a graph, and then also how you figure out the units and interpret what that slope means. In this case, the slope is telling you that there is a positive acceleration. All right. And it's supposed to be positive because this point is higher than this point. if this answer was negative, that's not a bad thing. Because, for example, this point is lower than this point, right? So if this was our second point of interest, then our slope should be negative because we decrease, okay? So just because you get a negative number, that doesn't mean you did something wrong, all right? You have to look at your graph and interpret it, understand what it means, right? If this point is lower, then that means you're going to have a negative slope. This point is higher in this case, which is why we had a positive slope. All right. Thanks for watching. Catch you next time.